Welcome, everyone. This is Sun, one of the co-organizer of TensorFlow Korea user group. We have a bunch of other co-organizers on this call as well today. Just a brief introduction of TensorFlow Korea user group. It was founded right after the AlphaGo match in 2016, and now is one of the world's largest TensorFlow user group, with celebrating soon the 50,000 members. And with that, we prepared an interview series to celebrate that. And today, the first one we are having here, we invited Laurence Moroney, the Google TensorFlow team's developer advocate. So welcome,
Yay.
Laurence. Thank you.
Yay.
Yeah, thanks for joining.
감사합니다.
Why don't you say hello
Welcome.
to TensorFlow Korea user group members?
Sure. So I hope I say this right. 안녕하세요.
Oh,
Oh, nice.
Oh, nice.
So thank you so much for hosting me. I've gotten to visit Korea many times over the last few years, and I'm really looking forward to going back and having a good bulgogi. And so first of all, also obviously massive congratulations on reaching the 50,000 users. My name's Laurence. I'm the lead developer advocate at Google for TensorFlow. Really, my job is all about helping developers grow with their skills with machine learning and AI. I always like to demonstrate that there was a research done in China a few years ago that said there were 300,000 AI practitioners in the world. But lots of other research shows that there are about 30 million coders in the world, about 23 million professional coders, and about 7 million like enthusiasts. And so if we could produce a framework, and if we could produce material that's aimed at the 30 million developers, we could increase the number of AI practitioners in the world by 10 times if we only reach 10% of the developers. So that's kind of been my mission for the last 18 months. And so to that end, I've been producing, I own the TensorFlow YouTube channel, so producing lots of stuff on that. I teach courses online with Coursera, with the folks from deeplearning.ai. I know Andrew Wang did a video with you, I think was it last month? And so he and I teach courses on there together. And really the overall vision that we have is really to turn machine learning and to turn AI into a tool for the general software developer, as opposed to the deep mathematician, the deep ML person, that kind of thing, and to normalize it so that, 4 or 5 years from now, we're hoping that machine learning will be as normal a part of a developer's toolbox as HTML or JavaScript or CSS or Java or whatever, that kind of thing. That's where we're trying to take it.
Okay, thank you. All right, then let's move on to the questions one by one, which we received from our members. The first one, you've been putting a lot of effort to help developers learn machine learning and TensorFlow. Any words or advice for those who started to learn machine learning and TensorFlow for the first time?
Oh, yeah. First of all, I think the main one is don't be scared. I think it's very easy when you start looking at a lot of this stuff, and particularly when a lot of the material is heavily mathematical, to be scared and to think you can't do it, and to suffer from imposter syndrome, to say, this is deep calculus, this is complex mathematics, and I haven't done complex mathematics in however many years. And it's very easy to be put off by that. So don't be scared of that. And then if you are a coder like me, to start really looking at scenarios that can be easily achieved using coding, where you don't have to worry about the math. And that's really what TensorFlow is all about, what the high-level APIs in TensorFlow are all about, particularly Keras, so that you can start thinking about designing neural networks to solve problems like natural language processing, image classification, computer vision, sequence modeling, those kind of things, without that deep understanding of math. Once you have that deep understanding of math, it helps you build better models. But often when I work with people who want to get into machine learning, that they're put off by that. University courses and a lot of training courses tend to teach you machine learning, where machine learning is the discipline about how machines learn. And how machines learn involves a lot of calculus and all those kind of things, stuff called gradient descent and that type of thing. But you can use machine learning in your code without understanding how the underlying math of machine learning works. And as a software developer, I encourage you to kind of look into that. The analogy I always like to use is, say you write in a language like C++ or Java, you can write your code in C++ and Java without understanding how a compiler works. And it's the same with machine learning. You can write your code to build machine learning models without understanding all the underlying math about how machine learning works. So if you're just getting started with that, that's the number one thing that I've seen that put people off, is that they get scared by that math, and you don't need to be. So it's that, I would say, is my first advice. The courses that I've been teaching have been teaching with that focus. Is that, say you're a coder, you only need to know a little bit of Python. With a little bit of Python, you can go a long way. And before you know it, now you're building models that are using gradient descent, that are using all of this complex math. And if you want to go into the math to help you do your models better, then you can do so, but you're already successful before you reach that point. Does that answer the question?
Yeah, excellent answer. Thank you. And then let's move on to the next question, which we received from one of the member, Tae-jae Nim. Where do you think the future of ML is heading for? In what ways do you think the COVID-19 pandemic also has affected in the future of AI?
So I'll start with the first part. Where do I think the future of ML is headed? For me, the ideal future for ML and for AI is that it becomes normalized. It becomes just a part of every developer's toolbox. It's not a special thing anymore. And that's when it will become successful. Consider once upon a time, maybe 10 years ago, and we were all writing desktop applications, Windows applications, those kind of things. And then the mobile came on the scene. Apple in particular released the iPhone, and the concept of a mobile developer was born. And then a mobile developer was a very special and different and distinct thing. But now mobile skills and being able to build for mobile skills should be a part of every developer's toolbox. And I think for machine learning and for AI, the ideal future for that, and where I think it's heading and where we're trying to drive it towards, is that it becomes a normalized skill for every developer. And if we can succeed with that, then the world will succeed with AI-based applications, because you'll have 30 million developers building them as opposed to 300,000 developers building them. So that's where I think it's heading, and that's also where I'm trying to drive it. And I'm really, really excited about that. And then the second part of the question was like, how do I think the pandemic has affected the future of AI? That's a great question, and I really don't know how to answer it, because it's too soon. I mean, the pandemic, awful as it has been, has only been a few months. Obviously, there's been massive disruption over those few months, but whether that disruption for those few months has a longer term impact for AI, I don't know. I'm an optimist, and if anything, I think the new normal that we'll adjust to after the pandemic passes might actually be beneficial for AI, because there's going to be a need for new applications. There's going to be a need for new classes of application. And there's going to be applications that people are going to need that nobody ever thought of. And if developers are using the ML AI toolkits properly, there's a lot of scenarios that nobody ever thought of that you can actually build quicker if you're using ML-based ones. So the optimist in me thinks that it could, in the long run, be good if you have AI skills, that all these new opportunities can come up as a result of whatever new equilibrium we reach as society once the pandemic has passed.
Okay, thank you. And then let's go on to the next one. Let me ask Hoyeon Song, ask directly to you.
Sure.
호연님, 직접 질문해 주세요.
Hello, Laurence.
Hello, hi.
So yeah, I want to ask you, what's the future roadmap of TensorFlow 3.0?
Okay. So I hear Sun laughing because at Google we have a rule that we're not allowed to speculate about future roadmaps of any product.
Yeah.
And but one of the things I can say is the trends that we're trying to drive with TensorFlow 2.x and beyond into TensorFlow 3. There's really two main ones. The first one, the one that I'm more passionate about, is making it easier. So you can see with TensorFlow 2, we invested very heavily in Keras and in having Keras become a first-class citizen in TensorFlow. And a lot of it is really, that work is not yet complete. There are still things that you do that are half old Keras and half new Keras. And as we continue to invest in moving into towards TensorFlow 3, I think a lot of that should become more native TF.Keras. Let me give one example. One of my favorite things in Keras is image augmentation. And image augmentation was often done using the image data generators within Keras. But as you can see, we're beginning to ship the image augmentation libraries into the mapping functions that you can do with TensorFlow data in native TensorFlow. So things like that, you'll begin to see that a lot of those kind of things that were very half and half are becoming more and more pure TensorFlow. And that follows really along the theme of high-level APIs that are very easy to use. Another aspect of that then becomes extensibility. So, and that's the second thing, is to make it, the first thing was to make it easy. The second thing was to make it powerful. Particularly powerful when it comes to researchers. That one of the things that I hear a lot from researchers when I talk with them is they love TensorFlow, they love Keras, they love doing things with high-level APIs, but once they start doing something with a high-level API, it's very hard for them to defend that in a thesis. So if they use image augmentation, like I mentioned earlier on, and if you're not familiar with it, image augmentation is a way that you can do various transforms to images to prevent a model overfitting to your training set. But if they start using image augmentation techniques as an example, then when it comes to defending this in research, it might be hard to do so because Keras introduces a lot of randomness to that, and they don't know the randomness without breaking open the source code and going into that, et cetera, et cetera, et cetera. So having extensibility on Keras layers and having that ability to extend and go deep into what's going on in Keras and what's going on in TensorFlow, then is something that will help make it more powerful for researchers. And then, of course, on the theme of power is being able to use new hardware. We're continuing to invest in TPUs as an example. So the TPU infrastructure for you to be able to train fast on obviously is very important, particularly as models move into production. Often models, you don't just build a model once, you put it into production and you're done. Very often you build a model, you put it into production, but then you have to update that model regularly. Let me give an example is like shopping sites. You're probably familiar with Amazon.com. Amazon.com have a recommendations engine. A recommendations engine, so if you originally bought this, then you'll also likely to buy this. Those recommendations engine require constant updating. So if you have to train a model and constantly be retraining a model and pushing new models out there, the quicker you can train them, the better. And as a result, that kind of power to be able to support new hardware as we continue to drive new hardware like TPUs, of course, is huge. So that, I would say, is like, as we move towards the future of TensorFlow, not any specific version, those are the trends that you're going to see. Number one, making it easier, and number two, trying to make it more powerful.
Thank you.
Thank you.
감사합니다.
Okay, and then, thank you. And then let's move on to the next one. Let me ask Sung Kim to directly ask question to you, who is also one of the co-organizer of TensorFlow Korea user group.
Yeah, so I saw many videos of TensorFlow JavaScript about from you, and then also I know that you are an expert in the area. So I saw many examples, but what would be the best or maybe killer example for the TensorFlow JavaScript?
Oh, wow. That's a great question. So there's a person on my team, his name is Jason Mays, has taken over doing the JavaScript stuff, and he knows far more than I ever would. So I definitely recommend taking a look at some of the stuff that he's been sharing on social media, and there's some amazing examples out there. The one that he built that I've seen recently that I thought was a killer example was I don't know if you've seen it, but it's an invisibility cloak. Kind of like Harry Potter's invisibility cloak, where he has a webcam, the webcam sees the background, and then it calculates which part of the background he's obscuring. And even if he moves around, like I'm moving around now, it actually obscures him and replaces with the background, effectively giving an invisibility cloak. And which I thought that was amazing. I mean, it's not a hugely practical example, but it's an amazing example of how powerful JavaScript can be when combined with machine learning. And he's continuing to put together, he's calling it superpowers, samples of superpowers. So invisibility is one superpower. Another one was teleportation, where I don't know if you've seen another example of like taking a picture from a magazine and taking that and putting it into augmented reality. And even now using PoseNet and using like facial animation to take a character from a magazine, put it into augmented reality beside you and actually have it talking. So some of those examples, they've blown my mind with what is possible in the browser when you start taking some of the great frameworks that are out there and then combining them with machine learning. It's really, really nice.
Thanks. Definitely, I will take a look at them. I have a second question on that.
Sure.
Basically, when I see that these demos, it's really fun, and then it's a good demo. But do you have any, maybe internally in Google, do you have anything that you are really using TensorFlow JavaScript for the production anytime soon, or any plans?
I can't think of any right now that we're using in production. I know the one that I'm most excited about using JavaScript is some of the things that we're talking about as a potential. And that is when you combine with backend stuff. So for example, Node. So instead of running in the browser, but running on a Node server, and when you realize things like Cloud Functions and Cloud Functions for Firebase run on a Node server, we could potentially put together something where you have a model running in JavaScript on a Node server, and Cloud Functions then run off of a trigger. And the scenario that I was talking about earlier on in production, where you want to constantly be retraining models, that you could potentially have a scenario where you have a model, a JavaScript-based model in a Cloud Function, and then a trigger happens. Like maybe somebody buys something on your website, that could be a trigger, which then triggers something to retrain itself in response to that, as opposed to me as a developer trying to figure out, I want to retrain it every week or something like that. And then have that train a new model and have that deploy a new model and have all this happening automatically. Because Cloud Functions work on Node, this is only possible in JavaScript. We can't do that with Python-based models unless you have a Cloud Function spin up a virtual machine. That virtual machine has Python code. You then want to train with that Python code, get the model, and it gets really complex. The simplicity of having JavaScript on Node there with Cloud Functions, I think, is really, really exciting. And we might start seeing some products use that. There are none in production right now, but I think that's something that you're going to be seeing a lot of.
Yeah, that's very interesting. Thank you.
Oh, thank you.
Okay, thank you. And then question from one of the TF-KR member, Gojemi-nim. I'm going to apply colleges this fall. My question is, which classes or courses in college did you find the most helpful in terms of your machine learning career? And how could I make the most out of it during my 4 years in college?
Okay, so my advice there is not going to be very good, I'm afraid, because I went to college a very long time ago. And the kind of classes I studied in college, the languages I studied were like Pascal and Lisp and Prolog, which nobody studies anymore. So I can't really give any advice on what would be helpful from what I've studied. And also my degree was actually physics. and as opposed to computer science, I changed to computer science later in my life. So can't really give you a good answer there, I'm afraid, but from my experience. But what I would say that is the most helpful in terms of your college learning career, particularly in the latter years. So if you're doing 4 years, particularly in years 3 and 4, is networking. And I don't mean the technology of networking, I mean networking with people. Joining community groups, joining and being involved in community groups, trying to get a good internship and being involved in that internship. Because one of the unfortunate things about our career and our business in computer and in computer science is that everything changes so quickly that often industry is very far ahead of university. And even when I studied in university, like I said, I studied languages like Pascal and Lisp and Prolog. By the time I graduated, all the jobs were in something called Visual Basic, and we didn't study Visual Basic in college. So as effective, and in many ways more effective than just your classes, would be to do that kind of networking. And I want to share an example of, I'm based in the Seattle area, and we have a Google developer group in the Seattle area, and I speak at that from time to time. And there was one night about a year ago, I spoke at the Google developer group in Seattle, and there was a young lady who was at the group, and she was just finishing college, and she had spent her last 2 years going to every Google developer group, every Apple developer group, every Microsoft developer group, every Amazon one, spending as much time as she could in that and networking with as many people as she could, to the extent that it got her an internship in Microsoft the year beforehand, and then she was graduating and moving straight into an amazing career. There's a telecommunications company in Seattle called T-Mobile. I don't know if they're popular or if you're familiar with them in Korea, but they're one of the biggest employers in the Seattle area, and she was able to move directly into a career with them. And this, to me, she was the ideal model for how I think somebody should study in their undergrad. Your classes are, of course, super important, but in our field, because things move so quickly, you have to, find some time in your last couple of years to do that kind of networking as well.
Thanks for the advice. Definitely gonna focus a lot on networking and making a lot of friendship groups and joining a lot of those developer groups.
Yep. And one small thing is I've noticed as I travel around the world and I speak in developer groups that often the sponsors of the developer groups are employment agencies. And so they do that because, employment agencies make money by taking somebody and placing them in a job. And so when you go to these developer groups, you're getting exposed to these employment agencies. When you're sharing at these developer groups or doing presentations, then the agents from these agencies are going, wow, this person really knows machine learning and AI. I'm going to send them to my customers. And as a result, everybody wins, right? The company wins because they find a good candidate, the agency wins because they get paid, and the candidate wins because they find a good job.
Supply and demand.
Okay.
Supply and demand.
All right, thank you. And then we have one live question from YouTube comment. I know Google is doing a lot of research on AutoML. What kind of development plan does TensorFlow have in relation to AutoML technology?
Right. So, AutoML uses TensorFlow under the hood. So the idea behind AutoML, for those who aren't familiar with it, was that AutoML, a lot of it is to have a machine search for the best architecture to do machine learning, as opposed to a human tweaking the hyperparameters. And so the idea behind AutoML is that if you have enough compute power, you could go through every possible combination of layers, how many neurons in a layer, or how you're going to design your layers, and all of those kind of things to find the most efficient model. That's ultimately, what AutoML is all about. And we found that in many research-oriented models, that the results are better once AutoML has been applied. But of course, in order to be able to build models using AutoML, you need a massive compute infrastructure, and most people don't have that massive compute infrastructure. So what we've done at Google is we're providing that as a service. And so a lot of the stuff that we've been doing around AutoML, productizing it, is providing it as a service so that whatever your scenario is, you could take advantage of our infrastructure, to have our infrastructure do the neural architecture search to be able to come up with the best possible model. So, you know, we work very closely with the AutoML people and the people in the cloud as a result, so that whatever feedback we're getting from them about how to make our neural architecture search better feeds into their AutoML product. And it also kind of feeds back to something I was referring to earlier on the roadmap for TensorFlow 3 about making it simpler, was that like some things are kind of half KRS and half TF.KRS. And as we move more and more of that towards full KRS, then it's going to help out with neural architecture search as well.
Okay, thank you. Another question from another co-organizer of TF-KR. What's
Sure.
the easiest way to convert a TensorFlow model to another framework or vice versa?
I don't believe there is an easy way. So if you're talking about like a finished model, to convert that to, for example, to PyTorch, I really don't know of any reliable methods for doing that. If you do want to kind of go over and back between like PyTorch and TensorFlow, it's probably the easiest way to do that is at the source code level. So you take a look at how you've defined your model architecture pre-training in TensorFlow and translate that code into PyTorch and vice versa. That would be the only main way that I could think of really doing something there. The alternative, of course, then is when you think in terms of transfer learning. So that if you're taking a pre-existing model and that pre-existing model is in a format that's compatible with whatever framework you're using, and you're using transfer learning, then you typically only define 1 or 2 layers at the bottom of all the existing layers, and then those are the only ones that you'd have to translate between frameworks. But, you know, I'm not really familiar with any work other than that of like kind of migrating from one to another. Unfortunately, it has to be at the source code level. You know, it's like analogous to how would I move from C++ to Java. You don't do that by moving your executable, your compiled code from one to the other. You do it by translating your source code from one to the other.
Right. Thank you. Another question from YouTube, which I'm sure you will like. Question from Jebom Kim. I enjoyed your class in Coursera. Are you planning another classes in Coursera or other platform in the near future?
Yes. So first of all, thank you so much for enjoying the class. I'm having a lot of fun creating and teaching them. And absolutely, yes. Right now, I'm actually at work on that. I'm spending most of my time on it. Because of the pandemic, I've actually set up a studio in my home. I have all the camera equipment just off screen over there. And I'm presently writing and filming the next specialization. So on Coursera, my plan has been to do 3 specializations. The first one was called TensorFlow in Practice. The second one was a TensorFlow Data and Deployment. And then the third one is really Advanced TensorFlow. The Advanced TensorFlow specialization is going to go into things like extending TensorFlow, extending KRS, being able to write custom layers, being able to see what's going on under the hood, those kind of things, as well as then some of the more advanced machine learning scenarios like style transfer, generative adversarial networks, and you know, being able to create art and music and those kind of things with AI. So that's the course that I'm currently writing and filming. I'm hoping to have it done and have it out sometime later this year. And so that's really the goal for that. So I'm looking forward to seeing if people like that and if people enjoy it. Oh, and then there's one other, sorry, I forgot, is that in the second specialization, the TensorFlow Data and Deployment, one of the classes was on TensorFlow datasets. A lot of that has gone out of date, so I'm refreshing and updating that. I've actually just finished filming some of that today, so refreshing and filming that for the latest version of TFDS. So there'll be a new version of that course coming first, and then all the advanced stuff.
Okay, thank you. Another question which we received, question from Shashank Barkey. What's the best TensorFlow case study in 2020? And similar, I think similar question from Terry as well. What all the industry will take the biggest advantage of AI and be change it to AI-centered industry in the near future.
Okay, I'll start with the case study. I don't know if there's a formal case study published of this yet, but there was a talk at the TensorFlow Developer Summit, and there's a video of it on our YouTube channel. But the one that really excited me was the folks at NASA using TensorFlow. And two scenarios that they shared was one is on the space station. So they're using ML models on the space station for monitoring the environment and those kind of things, which I thought was really cool. But the one that really blew my mind was the next Mars rover. One of the things that they're considering with the next Mars rover is to have ML models on that one to get over the time delay with the rover talking to Earth, somebody on Earth making a decision, and then the decision being sent back, and then the rover responding to that. That an on-device model on the rover could make a decision based off of the data that it has. So like the joking thing that they did, they had like a little graphic for it, is like if the rover actually saw an alien and like maybe that alien was moving, that the camera could just decide to move to follow it and take more pictures, as opposed to something moved, the camera sends something back to Earth, it takes 8 hours, somebody makes a decision to move the camera to the right, they send it back to the rover, 8 hours later, the camera moves to the right, and of course the alien is gone. And I know it was just a joking scenario, but the concept of being able to have that rover being able to make intelligent decisions without relying on, or depending on the time delay for human decision from Earth, that just blew my mind. And that's a beautiful, beautiful scenario for having machine learning, to have that level of autonomy on the rover so that, we can empower more scientific discovery. It's amazing. We've no idea how many potential opportunities to discover something that we've missed by the fact that the rovers have this time lag, and being able to use a machine learning model on the rover to get over that, I find really exciting. And that's the best thing that I've seen, the most exciting thing that I've personally seen in 2020. So to go back to the other question then was, what was it, an existing industry that can take the best advantage of AI?
Yes.
The one that I'm most excited about there, I think, is healthcare. And I have to be a little bit careful when thinking about that one, because I don't see AI replacing existing skills in healthcare, but I do see it enhancing existing skills in healthcare. And there's one example that Jeff Dean shared at Google I/O last year, and it's diabetic retinopathy. Is a disease where if not discovered, it's easy to treat and it's very cheap to treat, but it has to be discovered early. To discover it early, you need a qualified ophthalmologist. And in many countries in the world, and there are many high population countries in the world, and he cites India as one of them, where there just aren't enough qualified ophthalmologists. And as a result, a lot of people are going blind who shouldn't need to. And at Google, we have a data set. We've actually open sourced that data set if you want to build something with it yourself. And we built a model off of the diabetic retinopathy data set that is now as good as, in some ways, better and more accurate at discovering diabetic retinopathy than a qualified ophthalmologist. Now, it's easy to then jump into, well, then we could replace ophthalmologists with this, and I think that would be wrong. But where one ophthalmologist X people a day by having to, if you excuse the pun, eyeball the charts themselves, now using an AI like this, an ophthalmologist might be able to see X times 100 people a day. Or the ophthalmologist doesn't necessarily have to be in the same location as the person, or the same country, or the same time zone. And as a result, like those kind of things, that the social benefit of that is huge. And the industry benefit of it is huge, because with an ophthalmologist being able to see more people per day, an ophthalmologist can bill more people per day, and the career can be better. And if they're seeing 100 times the people, they can obviously reduce the price, and that can also bring down the price of healthcare. And in many countries, particularly the United States, healthcare is crazy, crazy expensive. So I think, some industries that can take a great advantage of AI and change to an AI-centered industry can be very, very good for everybody. And I know there's always like there are naysayers and there are negative people out there who start talking about, well, AI will take jobs away. I honestly don't believe that. Every time you've seen a new and disruptive technology that makes somebody's job easier or better, some classes of jobs go away, but the overall job market actually grows. And I think, you know, that's the kind of thing, the kind of trend that I see happening, and I find really exciting.
Okay, thank you. By the way, as a reminder, we are having this interview with Laurence Moroney in celebration with TensorFlow Korea user groups, 50,000 members approaching. And we originally thought this is for Korean people, but thanks to YouTube Live and other methodology, we see people from all over the world. And I see from YouTube, I know this guy because he's my colleague, Anidi, who is living in currently in Nigeria, hosted a question here. So I'm taking my advantage to as a host to forward Anidi's question to you.
Sure. Sure.
Are there any practical applications for child transfer? It definitely is cool, but what could it be used for? By the way, and thanks for providing the introductory content for my course.
Practical uses for style transfer. Ooh, it is very cool. It is a lot of fun. Hard to think of one right now. One that kind of just does jump to mind, although it might be a little bit of a stretch, is education. And particularly like style transfer is very cool in art. And I know some folks who go to art school and they spend a lot of time learning how particular people paint in particular ways. And maybe style transfer is something that can speed that up. So like you take your painting and you apply style transfer in the style of Van Gogh to it, and you can really learn about how you can improve your art his way, you know, in Van Gogh's way, something like that. That's one that immediately jumps to mind. Obviously, it's not a huge world-changing kind of thing, but not everything has to be. What else would I think of as a good application for style transfer? I might have to think about that when I get back to you on it. Sorry, I don't know of any offhand.
Okay, thank you.
Can you think of any,
Right.
Sun?
Maybe not at this time yet. Maybe anyone, Sung or Jimin or anyone. It's definitely a cool technology.
Yeah, I mean, one thing that I have found is that it has been great at introducing people to different types of art. The Google Culture app now has you can take a photograph and then you can use style transfer to turn that photograph into a number of different styles. I've learned about different art styles through that and being able to be inspired to look into those art styles as a result. But I can't think of any others.
Yep. All right. It's really great that we are all engaging, actively engaging together. We've been getting new questions as well. Now we have Go-Jae-min-nim he has one more question that he would love to ask directly by himself.
Mm-hmm.
First of all, it's a great honor to have you, Mr. Monroe. I've been taking your classes for like months. I'm binge watching during the quarantine life, and it's been really helpful to take your classes. I really appreciate a lot of your jargon. Yes. So my question is, I've noticed that there's currently a lot of research to get into the field of TensorFlow and get into artificial neural networks. But I've also noticed that the difference or disparity, should I say, between such beginner level courses and the current state-of-the-art level papers are somewhat large. So what could be the gap closer? What could be the intermediate level courses that I could take?
Yeah, great question. That is a constant struggle because the state-of-the-art is moving so fast, and that by the time you do create like some content, that the state-of-the-art has moved so far beyond you that you're back to beginner type content. Like in my Coursera course, one of the things I teach is the cats versus dogs classifier, which 4 or 5 years ago was state-of-the-art computer vision. Now it's beginners. It's a little crazy. So one of the things that I'm trying to do to close the gap is that next specialization that I was talking about. We've been trying to plan the specializations so that there would be 3. The first one is really all of the stuff now that an entry-level person needs to know. Computer vision, natural language processing, sequence modeling, and all of the frameworks around that. The middle one was all of the stuff that the developer needs to succeed. So how to deploy it and to like mobile, how to deploy it with TensorFlow.js to the web, all of that kind of thing. And then the third one, the one that I'm currently working on, is kind of like to bridge that gap to take the beginner and make them more advanced so that they could start to really understand a lot of the state-of-the-art stuff that's out there. So things like generative adversarial networks, object detection, image segmentation, and all of those kind of things that, while the beginner stuff was state-of-the-art 5 years ago, this stuff was probably the things that were state-of-the-art 2 years ago. And by the time we publish it, it might be 3 years past state-of-the-art because the state-of-the-art is moving so fast. But the idea is to at least try to teach the developer those kind of things so that when they start looking at the volume of papers that are being produced, that the families that those papers, the state-of-the-art papers are in, are the kind of things that you're beginning to learn the elements of. So like we see like a lot of papers being published, for example, around generative adversarial networks. A lot of people don't understand what they are. You learn image processing as a beginner, it's hard to join the dots. So that's the kind of thing that I want to cover in the next specialization.
Thank you.
And after that, there may be a 4th one to get closer to whatever the new state of the art is like 2 years from now. I don't know, but the plan right now is for those 3.
Okay, thank you. Also taking the privilege and advantage of being the host here. Another question from Africa, Muhammad Muralta. I know him, but I forgot which country he is in. This is actually a question to everyone, Laurence, and especially the organizers and co-organizers of TensorFlow Korea. Hi everyone, congratulations to TensorFlow Korea for reaching such a milestone of 50,000 members. I would love to know how you reached such a milestone. It could be a great lesson for other TensorFlow user groups worldwide.
I'll let you guys answer that one.
Yeah, this is also one way to give Laurence a small break.
Yeah, thank you. Thanks, Mohammed.
but yeah, so Song or Jimin or yeah, do feel free to jump in, please.
Just let me share some thoughts. I think one of the reasons that so many people are interested in is, of course, thanks to the TensorFlow. So TensorFlow is a very easy tool that a lot of people want to use it. And then thanks to the support from the Google, like for example, like today's events, we actually were very happy to have Laurence in here and then have wonderful events in the TensorFlow Korea. So actually, we, like for last few years, we had many interesting events. Actually, the good idea is coming from Sun and then Jimin, Chris, everyone in the TensorFlow group organizers. So actually, we had many events like today's, so it can attract a lot of people from each event, and then those make things like a group bigger and bigger. That's my thought. And thanks a lot.
Any words?
Yeah, Laurence. Yeah.
Thank you.
Oh, my pleasure.
Yeah, after this, for example, after this event, we'll have one more like 100 or 200 more members.
Great.
Yeah.
Yeah, I totally agree with that, and I especially thanks for Google to like very big support for every event. Yeah, as Sung said, so that's the key to make our it's very hard to answer on like live, but yeah, so yeah, that's the big key. issue for us. And also we have very big members. So yeah, every member can really have a question about the TensorFlow in our group page, and then other members can answer for that. So it's our big advantage for us to have increase our members. So yeah, that's anyway, thanks Google for supporting us.
Thank you.
And yeah, we will have our best to make our community bigger and bigger.
Great. Chris or Jinwon, any word to add? Okay. Maybe I can also add some more comments here. Yeah, we are definitely happy about happy about reaching this milestone, and this was a really great journey throughout from the beginning to till now. I think one thing that kind of helped was, as Sung mentioned, that the role of organizers is critical in constantly brainstorming and thinking about what we can do for the developers and members. That was all. And how can we make some cool, exciting activities together that helps them. So as long as we continue as long as you continue taking care of your developers and members and trying to do something, the key is just continue doing something and iterating and experimenting and then moving on. And also now that we have these TensorFlow user groups worldwide as well, and I know we are connected each other. So as long as we continue doing something individually and then sharing and then ask comments and ask feedback to each other, I think that would be a great way to grow the communities in each countries and regions, as well as also all of us grow into a global, bigger network, community of network. Okay.
Totally agree.
Thank you. Any last words? Any comment from Laurence?
Just one is that I found that successful communities don't have to be big, and it's great to have a huge community and to kind of go to 50,000 people. That's just amazing. But sometimes other communities might feel, I've only got 100 people in my community, I'm a failure. And you really don't need to be big to be a very effective community. And so that's the first thing. So, don't feel bad if you're watching this and you're in a place that, is a smaller country or something like that and doesn't have as many people, or a smaller city. You can still be very powerful with a very small number. I've spoken at a number of community events around the world where there's 20 people, but they have an amazing community and they do great things. So, don't feel it has to be a large one for it to be successful. And then the second one that I would say is that the leadership of the community, that the folks who are the best leaders are the folks who are just the same as the people who are in the community, standing shoulder to shoulder with them, sharing their own struggles with them, that the best and most powerful communities that I've worked with are the ones who've done that. And as opposed to, hey, look at me, I'm successful, and I'll show you how to be successful. The ones that it's like, no, I've struggled as a developer, I've had my problems, I still have my problems and my struggles, and to kind of really, like I say, be shoulder to shoulder with the members of the community like that are the ones that really build the rich, powerful groups.
Thank you. That's great. Okay, and then let's move on to a few more questions that we also received from YouTube. YouTube question from YouTube from Danny Doan Kim. Among those famous AI tasks, such as detection, segmentation, or language understanding, what is your favorite task, and which task do you think is the hardest one to implement?
Okay. Oh, wow. I think my favorite tasks are the ones when AI creates something. When like a model is trained, like we talked about style transfer earlier on, and something like that where we begin to see the machine almost expressing itself. I find those are really exciting. I was in Japan last year, and I was doing a talk at the university, and a number of students were doing a show and tell at the university. And it was amazingly prophetic at the time. But what they did was that a lot of people in Japan, and I'm sure Korea is the same, already wear face masks. And by wearing a face mask, the lower half of their face was obscured. And what these students did was that they trained the model on a data set to say, well, when the upper half looks like this, predict what the lower half would look like behind the mask. And they made me stand in front of a camera, and the camera took a picture of the upper half of my face and then predicted what the lower half of my face would look like. And it actually did it really, really well. It was, that kind of generative stuff I thought was really incredible. And we've probably all seen those AI that generate art. I've seen some that generate like anime characters, some that generate text. That kind of stuff is what I personally find really, really exciting. The hardest of them is probably natural language processing. If nothing else, because we have so many languages in the world, it's, I only speak English fluently. And when I work with natural language processing in English, it's hard enough. Forget it to be able to do anything in Korean or any other language. But I think NLP also potentially has the best and greatest impact as we go forward. But because language is so irregular, it makes it very difficult to do. So I think, yeah, my favorite is generative AI. The one I think is most difficult is really, really good natural language processing.
Okay. Thank you. I think we can, have 2 or 3 more questions and then wrap this up. Okay. Question from Terry. There are lots of students who considering to go to PhD program. Who do you think should go to PhD, and who do you think who should directly go to the industry?
Oh, good question. I think my only answer that I can really give on that is that it really depends. I think if you are interested in a role in industry that needs you to go deep, that needs you to really push the state of the art, like, for example, being an engineer at Google who's building the next generation of TensorFlow, or who's designing the next generation of it, or who's optimizing it, that kind of stuff, those kind of things that where you're really pushing the curve, probably need a PhD. Sometimes lots of industry experience without a PhD is enough, but that kind of thing, you probably need a PhD. If you want to go into research and those kind of things, of course you need a PhD. If you want to go into industry and just be a software developer, so that instead of pushing the edges of what the framework can do, instead you're using the framework to push the edges of what the developer can do, you don't necessarily need a PhD there. So I would say that you really want to consider, what is it that you're passionate about? What is it that you could see yourself really enjoy yourself working at? And there's the old saying that if you love what you do, you never work a day in your life. And so if you think about what is it that you would love to do, and think about then the qualification that gets you there. I've never done a PhD. I do not have a PhD. It's one of the biggest regrets in my life that I didn't do a PhD. But it also meant that I was able to be successful without a PhD. So it's, like I said, it really, really depends on your career path.
Okay, thank you. All right, then last question. I'm happy to have Jimin to ask directly to you.
Sure.
Okay. First of all, once again, it's my great honor to ask my question to Laurence directly. So thanks for being with us. So my question is, what is the most challenging thing for you while working as a developer advocate?
Wow. Well, first of all, the honor is all mine. Thank you so much for hosting me today. I've really enjoyed this. No, thank you so much. I'm looking forward to coming to Korea that we can do this kind of thing in person. The most challenging, the most challenging thing as a developer advocate, I think, is there's only so many hours in the day, and there's so many things that need to be done that it's things move fast, things change fast, and it's being able to identify what has the most impact on the most people that I can do, that I can use my time most effectively for, is really being able to identify that. And then once I've identified that, and being able to work with the team to be able to deliver that. And when sometimes some things take a long time, like for example, the thing that I'm probably most excited about that I work on at the moment is the Coursera courses in teaching. And but it takes many weeks and many months to film them, get them out there, build an audience and all that kind of thing. But the environment can change in that time. Software can go obsolete, new releases can come out, and that kind of thing. That makes it very, very challenging. But I grew up in Ireland, and in Ireland we have a saying that nothing worth doing is ever easy. And because this is so difficult, that's the kind of thing that really makes it worth doing and makes it so much fun.
Yeah, it should be very challenging, I think. Yeah, thanks for your effort about your TensorFlow introduction course and many things. Yeah.
Oh, thank you. Thanks so much.
Thank you so much.
Yes, thank you everyone also joining for this interview series. We love to operate on time, and exactly now it's exactly 11 a.m. here in Korea. So yeah, let's again thanks Laurence for joining, and also thanks to TensorFlow Korea user group organizers and members who participated this, and also all the other global worldwide developers who are also joining from YouTube live channel today. Yes, thank you everyone.
Thank you.
It's I don't know how to wrap this up, but all I can say is thank you, and I will let Laurence to say a proper thank you and goodbye for this one.
Sounds good. Thank you. So yeah, just like a closing statement, I guess. So well, first of all, for everybody who's attended and everybody who's put up with listening to me for the last hour, I just want to say thank you so much. And 감사합니다 in Korean. And for the folks all over the world, I'm sorry, I'm not sure where you're from, but I'll try to say thank you in your language if I ever see you. And I think, one of the most important things as we move forward is to be able to move forward as a community despite our differences. With the things that are going on with the current pandemic, we're actually learning a lot about how to work with each other remotely and how to work effectively together despite our differences of location, differences of opinion, differences of country that we live in, and all those kind of things. And I think every problem is also an opportunity. And I think there is a great opportunity for us as developers and for us as AI and machine learning folks to try to make the world a better place. And now is the time for us to be able to seize that opportunity. It might be something very small that you do to, build a better app for your end users. It might be huge by coming up with some kind of scientific discovery. There's a massive spectrum of impact that you can have. And the first question that we asked today was like, how do you get started? What's the first thing that you should do? And I was saying, the first thing you should do is not be afraid. And I think, that's one of the things that right now there is a massive opportunity in front of all of us. And I think it's good for us not to be afraid to seize that opportunity. And so, by being part of a TensorFlow community, a part of an AI and ML community, you're already beginning that. And I just say, keep going, continue, don't stop, and keep doing what you're doing. And thank you so much on behalf of Google and on behalf of the TensorFlow team for using our technology. And we really, really appreciate that. And we're so humbled by the fact that you're doing it. So thank you.
All right. Thank you. And also especially thank you for the developers outside of Korea. I see from YouTube once again a bunch of friends, especially from Nigeria. They say it's 3 a.m. here there. So
Oh, wow.
right after this
please go to bed and sleep. Thanks everyone, and bye-bye. Goodbye.
Have a good day. Have a good night. Thanks. Bye.
오.
할게요.
네네.
고맙습니다.
수고하셨습니다.
감사합니다.
네.
네, 함께 해주셔서 감사해요. 바이. 행복한 하루 되세요.
네.